Hi, I'm Nicholas-DiRico.
Oh, hey there! I'm Mark from Barua.
And this is Derivatives.
A Barua-DiRico Production.
So, a lot of people ask me, how do you find a derivative? Well, to answer that question, we gotta take a look at what the definition of a derivative is. The word is derivative.
Derivative. Can I get a definition of derivative?
Derivative. Noun. An expression representing the rate of change of a function with respect to an independent variable.
Okay. Could you use it in a sentence?
Take the derivative.
Well, how do you take the derivative?
For our first example, we have the function y equals 2x. Now, if you notice the x points on the graph y equals 2x, the y values are increasing at a constant rate of change of 2. Therefore, if we were to graph this constant rate of change, otherwise known as the derivative, you'll see that the function would just be y equals 2.
Oh, hi. Notice that when we write the derivative, there seems to be an apostrophe next to the original function's notation.
This is an important concept with derivatives, as they are written in a different notation than the original functions. For f of x, it becomes f apostrophe of x. For y, it's just y apostrophe, or it could be written as dy dx. So, when you take your tests, if you see this notation, know that you will be taking the derivative.
Oh, God. Sorry there. Just doing some, light reading. In this Barua-DiRico lesson today, we will be teaching you 4 different strategies to taking the derivative.
Muy rico. On a hot summer day such as this one, the only thing that gets me through the day is a tall glass of cool milk and the power rule. The power rule is an excellent strategy used to determine the derivative. For example, one must take the exponent of the original function, multiply it by the coefficient, and then take the original exponent of the original function and subtract 1 from it.
For example, if we have the function x squared, the derivative would be 2x because the coefficient of x squared is 1, multiply that by the exponent 2, and you get 2x. Now, we have to subtract 1 from the original exponent, so that would just leave us with 2x to the 1, which is the same as 2x. For 3x squared, the derivative would be 12x to the third because 4 times 3 is 12, giving us our coefficient, and 4 minus 1 is 3, giving us the exponent. For the function square root of x, things get a little more tricky. We must remember that the square root of x is the same as x to the 1/2. So, if we bring the 1/2 down and multiply it by the coefficient, we get x over 2, x to the 1/2 over 2. Now subtract that 1/2 exponent by 1, and you get x to the negative 1/2 over 2, or giving us 1 over 2x to the 1/2.
You know, one might say that flowers are one of nature's most precious gifts, but I would have to say that some other things are on that list, such as Louis Fonsi and the product rule. Now, the product rule is another strategy for taking the derivative. Say we have 2 terms in our function, a and b. Now, to find the derivative, we would take the derivative of a, term a, multiply it by the by the original term b, then we would add it with the original term a times the derivative of b. And voila, we have our derivative.
For example, let's say that we have the original function of 2x minus 1 times 4x squared plus 6. To take the derivative of this, we simply take the derivative of the first term, 2x minus 1, and we get 2. We multiply this by the original b function, if you will, of 4x squared plus 6. Then we add this to the original function of function a, 2x minus 1, times the derivative of function b, which would be 8x. Now, adding this together, you see that we get the derivative of 24x squared minus 8x plus 12. Sorry, I didn't catch you there. Another strategy that we can use on the everyday grind of the derivative lifestyle is the quotient rule. Let's say we have a function with a term on the top and a term on the bottom. Now, we'll refer to the term in the numerator as the high function, and we'll refer to the term in the denominator as the whole function, if you will. Now, by following the simple steps, ho d high, that means the original ho function or bottom function, times the derivative of the high function, minus high d ho, that means the original high function, times the derivative of the ho function, over ho squared, you'll get your answer.
Let's keep this short and sweet because, in all honesty, we need to get back to our Arthur. Let's say we have the function 2x minus 1 over 4x squared plus 6. Now, following the same footsteps of ho d high minus high d ho over ho squared, you'll see that the original low function, ho, is left as the original low function. That is multiplied by the derivative of the high function, right here. Then we subtract it from the original high function, 2x minus 1, and multiply it by the derivative of the low function, 8x. Now, that is all divided by the low function squared, ho squared, as explained earlier. Now, this all gives you the derivative, which is this all right here. Now, if you are a real calculus student, under no circumstance whatsoever, ever in your entire lifetime, will you ever solve this out. You listen to me right now. Never, ever.
Being a master derivative taker is tough work, and even the best of us need a nice recharging of the batteries every once in a while. The problem is, when you're a professional, you can try and take a break from derivatives, but derivatives won't always take a break from you.
No. No, it can't be. No. He forgot to use the chain rule! Sorry there. I just remembered an egregious error one of my past students made. To make sure you don't make the same mistake, let me explain to you our fourth and final strategy, the chain rule. Now, let's say we have a function within another function. While that may be hard to grasp, let me give you an example. Let's say we have the function, we have a function, and that function is squared. Now, to solve the derivative for that, we must take that original function and toss it out. Let's replace it with a. So now we have a squared. So, to take the derivative, we must do what we always do. So, the derivative will be 2a. But we must remember that there's another function that we still have a to solve. So it would be 2 times the original function, then times the derivative of that original function. So this is the same when it's square rooted or cubed or anything else when you are taking the road on the derivative path. So you must always remember, if there's a function and another function, you must do the outside function, the derivative of the outside function, then we must multiply it by the derivative of the inside function.
Thank you, Professor Arpin. An example of the chain rule he mentioned is, let's say we have the original function of 2x minus 1 squared. To take the derivative of this, we'd simply take the derivative as if it were a squared, so it would be 2 times the original function times the derivative of the original function, which would simply be 2. Multiply it all together, and you get your final derivative, 8x minus 4. Gee, Arkin, I guess you could say we've whipped up some great derivatives tips, huh?
Yeah, I'd sure say so. Hopefully, you'll be on a roll when you take your derivatives test.